Variables can hold different types of data known as data types. Common data types are integers for whole numbers, floats for numbers with decimal points, strings for sequences of characters. Then we have booleans for true and false values, arrays and lists for collection of values. So each variable is usually associated with a specific data type which dictates what kind of operations can be performed on that variable and how much memory is being allocated for it. Then we have naming conventions, something which variable has. Choosing meaningful names for variable is as crucial as it enhances code readability, maintainability, and variables names typically start with a letter or underscore, and it can be followed by letters, numbers, or underscores. The name should be descriptive of what the data holds. For instance, for example, a variable holding a person's age might be named age, making the code kind of self-explanatory, and it gets to a point where you don't have to describe the code, it can describe itself, right? And the scope and lifetime of a variable can vary. Variables are a scope which defines the part of the program where the variables can be accessed or modified. Scope can be local, meaning the variable is accessible only within a specific block of code, like a function or a loop. And it can be global, meaning the variable is accessible throughout the entire program. The lifetime of a variable refers to how long it exists in memory during the program's execution. Local variables typically have a shorter lifetime, only existing while the function or block they are defined in is being executed, whereas global variables persist throughout the program's runtime. Initialization and assignment of variables. So variables can be assigned. So let's say we initialize it. Variables can be assigned or initialized with a value at the time of their creation. Initializing assigns the first value to the variable. Once it's being assigned, it will a variable once initialized, a variable can be reassigned with a new value multiple times during the program's execution. The ability to change value is what makes variables so powerful and integral to programming. Then we have constants. So in some cases you might see a variable to hold a value that does not change throughout the execution of the program. Such variables are called constants. They are typically initialized with a value at the start and are not meant to be reassigned. Constants help prevent accidental changes to values that should remain fixed, such as mathematical constants like pi or any other mathematical value, or configuration settings. Then we have memory management. So behind the scenes, when a variable is created, the system allocates a portion of memory to store the variable's value. The amount of memory depends on the data type of the variable. Efficient memory management is important and crucial for development and coding, especially in large-scale applications, to ensure that the programs runs extremely smooth without consuming excessive resources. So there are some best practices for that, and some best practices is like using descriptive and consistent naming conventions, right? Then you have initialize variables before use to avoid unexpected behavior in the code or changes. Be mindful of the variable scope. To prevent unintended side effects, use constants for values that should not change, enhancing code readability. So in summary, variables are vital in programming as they hold and manage data, enabling dynamic and flexible code. Understanding how to use variables effectively is a foundational skill in any programming languages. So some advanced aspects, and to understand their role deeper in programming at a deeper level, we will be discussing variable declaration and data types. So when a variable is declared, the programmer typically specifies its data type. Although in some languages this is inferred automatically, the data type not only defines the kind of data the variable can hold or does hold, but also the operations that can be performed on it, and also the memory it occupies, right? Strongly typed languages like Java or C++, the type of data a variable can hold is strictly enforced. For example, if you declare a variable as an integer, you cannot assign it a string value later on without an explicit conversion. And dynamically typed languages like Python and JavaScript, variables do not require a type declaration, and the type can change as the program runs. The flexibility can make programming quicker in a way to not assigning the values again and again, but also increases the risk of type related errors. So some advanced data types, apart from basic data types, many programming languages offer more complex types such as enumerations, which stands for enumerations, short form enum. So these are used to define a variable that can hold one of a predefined set of values. Enums are useful for representing categorical data where the categories are known in advance, maybe sometimes days of the week, right? Then we have structures, objects. In object-oriented programming, variables can also be the instances of classes known as objects. These variables can hold complex data structures that include multiple attributes and methods, enabling more sophisticated data manipulation and abstraction. Then we have collections. Variables can also hold collections of data such as arrays, lists, sets, maps, dictionaries, and so on. So these allow for the storage and manipulation of multiple values within a single variable, enabling powerful operations like iteration, sorting, and searching. Then we have mutability and immutability. The concept of mutability refers to whether or not a variable's value can be changed after it has been assigned. So mutable variables, these can be altered after the initial creations. For example, lists and dictionaries in Python are mutable, meaning you can add, remove, or change items within them. Immutable variables, once these are assigned, they cannot be changed. Examples include strings and tuples in Python. Immutability can be beneficial in multi-threaded environments where variables being altered by multiple threads simultaneously could lead to unpredictable results. Then we have memory management and garbage collection. When a variable is created, the system allocates memory to its value. So managing memory is crucial, and managing efficiently is actually very crucial, particularly in languages like C++, where programmers have direct control over memory allocation and delocation. So there's manual memory management in languages like C++. Programmers must explicitly allocate and free memory using constructs like pointers to directly interact with memory addresses. There's automatic memory management in languages like Java, Python, or C++, C Sharp. Garbage collection, C Sharp, not C++. Garbage collection actually automatically reclaims memory used by variables that are no longer in scope or is being referenced in the code internally. So what this does is this simplifies memory management and can introduce overhead, leading to potential performance issues. See, it can simplify memory management. You don't have to do it manually, it is done automatically, but it can introduce overhead because it's an automatic process that is being done in phases or cycles. Garbage collection is done in cycles, so it can lead to potential performance issues. So variable scope and detail. Understanding a variable scope in detail is very, very important. So understanding the scope of a variable is essential for managing its visibility and lifetime. We have global scope, which is declared globally, right? Variables declared in the global scope are freely available and accessible from anywhere in the program. However, you should not overuse it. Overusing global variables can lead to tightly coupled code, making maintenance and debugging difficult, and it's not recommended that you do everything under the global scope. Then we have local scopes, declares variables declared within a function or a block and are only accessible within that specific area. So local variables are more secure and it reduces the risk of unintended side effects because their usage is confined to a specific part of the program. Then we have something called block scopes. So what happens is in some languages they offer block level scope where variables are confined to the block in which they are declared. Example, an if statement or loop. So this is particularly useful in complex functions and methods where temporary variables are used. Then you have something called shadowing and variable hiding. So in some situations a local variable may have the same name as a global variable. So this is called shadowing or variable hiding. The local variable temporarily hides or shadows the global variable, making the global one inaccessible in the local scope. While this can be useful, it can also lead to confusion and more memory usage, more overhead if not managed very carefully. So lifetime of variables is like it refers to the duration for which the variable exists in memory and it is closely tied to its scope. So we have something called automatic variables. So these are usually local variables. We have automatic variables, which is usually local variables. These variables are these local variables whose lifetime is limited or to the function or block in which they are declared, and they are automatically destroyed when the other block is exited. When the block is exited, the other block is being executed, it is automatically destroyed. Then we have static variables, right? Static variables is something different than this. These variables retain their value even after the scope in which they were declared or has been exited. Even if the code is being exited, another code is being executed. So this is they retain their value even after that. And even in some languages, the static keyword can be used to declare such variables which are initialized only once and can persist across function calls across the whole life cycle of the project, right? So it is basically used for some design patterns. That's kind of different from what the scope of this courses. Then we have dynamic variables. Languages that support dynamic memory allocation like C++ with new and delete variables can be created and destroyed at runtime, and their lifetime is controlled by the programmer, right? So some best practices for management of these variables would be first to minimize global variable, right? Use global variables very carefully, as they can make debugging and maintaining code more difficult. Second, use clear and descriptive names. This helps others and your future self, the future self that you will be in 6 months from now, understand and do what the variable does, and understand what the variable represents, reducing the likelihood of errors in your code, right? Limit scope. Declare variables in the narrowest possible scope to avoid unintended interactions with other parts of the program. Consistent naming conventions. Follow consistent naming conventions. Example, consistent naming patterns like camel case, snake case, or any other sort of naming convention throughout your code base to maintain clarity and uniformity. Avoid magic numbers. Instead of using raw numbers in your code, assign them to constant with meaningful names to make your code more readable and easier to modify. So in summary, this is what variables are, and variables are a very important part of programming. It is actually the building blocks of programming. They are not just placeholders for data, but they also play a crucial role in how programs operate and manage data. So understanding their intrinsic, their what should I say, the scope, the lifetime, the memory management is very essential for writing efficient, maintainable and error-free code, right? So think about it, like this is the basic blocks of programming. Then we have data types, memory management. There are a lot of scope for variables and how they are applied, right? So they are like a symbolic name or labels for values stored in a program's memory, right? They are very important for a program's memory. So think of it this way, like they allow programmers to work with data dynamically, right? So they are like symbolic names or labels for values stored in a program's memory, or accessing the program memory is easy via variables. They allow programmers to work with data dynamically, and which actually means that the values of variables can change as the program runs. So this flexibility, this type of structure is crucial because it lets you build more complex and interactive programs. Let's say you create in a simple calculator program, you would use variables to store the numbers, the user inputs and the result of the calculation. So always know that the naming conventions are being followed properly. Naming variables properly is important for code readability and maintenance. Typically, variable names should be descriptive, such as total cost for the total cost in a billing application, they usually start with a letter and include letters, numbers and underscores, but now scopes, declaration and initialization is again very necessary. So declaration refers to an act of defining a variable's name and type. Its initialization is assigning it an initial value. So in some languages these steps are separate, while in others they can be combined. And although it may look very simple for you to understand what variables are, this is actually the basic concept or the basic building blocks of every programming languages. Other than OOPS concepts, this is actually very important. So some common data types that I have told you about are like integers. So always remember, every programming language have something called int, which stands for integers, right? They are whole numbers, like without a fractional component. They can be minus, negative, positive, but they should be integers. They should be defined within the int concept. Then we have float, basically 3.14, which is the pi number, something which has decimal values, right? Then we have strings of characters like hello world, the default program in every programming language. So they are strings. Then we have booleans. They represent true and false values, which is often used for conditions, for like some program that you need some input from them, a yes or no statement, such, right? So think about it. What simple program you can write, maybe a personal organizer, and what variables you would need to develop the program, like event date and task description would be the first block of that. Then again we have data types, which is actually very crucial, and memory management. So going deeper into this concept, understand that different data types serve different purposes, and they are chosen based on the kind of data a variable needs to hold. Some languages require you to explicitly declare the data type. When you create a variable like int equals to x equals to 5, something like that, while others infer the value from the assigned value, like the assigned type, right? Some may require you to say int equals to or int x equals to 5, right? Some may be like this. The syntax may be like this, x equals to 5. So let's say this is for C#, int equals to 5, right? So this is the integer, the data type, the naming convention equals to 5, which is the value, 5 is the value that this data type hold, and this is the naming convention of the variable, right? So this is the name, this is the data type, and this is the value, which is equals to 5, x equals to 5. Now some programming languages, what they do, they infer the type from the assigned value. So x equals to 5. Now see that we have not declared it as an integer. x equals to 5. We have not declared, we have not specified the data type, but just because it is 5, which is a whole number, which is mostly used to represent integers, the programming language will infer the type from the assigned value, which is an integer, right? Then we have primitive types. These are the basic building blocks of data in a language, like float, booleans, integers. Then we have composite types. These are made up of multiple primitive types, like arrays, a collection of integers, uh, dictionaries, list, for example, or objects in an object-oriented programming, which can hold multiple types of data. Strongly typed languages, these enforce strict rules about data types. For example, you cannot add a string to an integer without explicitly converting it from one type to the other type. So this is actually a havoc for the developers, but this reduces errors and it can require more careful coding. So this does gives the developer a headache, but it requires more careful coding, right? Then we have dynamically typed languages. In some of these languages like Python, variables do not require an explicit type declaration. The type can change as the program runs, which makes coding quicker but can introduce type related errors, right? And we have already talked about enums, enumerations. It's used to define a set of named values like days of the week, states in a process, states in a nation. This makes code more readable and reduces errors, right? Then we have structures, objects. In object-oriented programming, a structure on an object can hold multiple pieces, maybe of related data. Like, let's say for example, you have a person object. So you have some multiple pieces that can be kind of a related data, like age, name, and address attributes, right? Then you have collections. Collections can hold variables, like variables can hold collections of data such as list, which is an ordered collection, sets, which is unordered collections without duplicates, and dictionaries, key value pairs. So these structures allow for more complex data manipulation. Then we have memory allocation. When a particular variable is created, the system allocates a specific portion of memory to store its value. The amount of memory that it allocates depends on the data type. Efficient memory management is crucial and very important, especially in performance critical applications. Let's you make some banking application, so it is a very performance critical application, so it's very, or even a game of a real game, multiplayer game. So efficient memory management is very crucial in these performance critical applications. So you can think of real world objects like a car, and you can think how they can what represent them, how you can represent them as variables using different data types, right? And the scope of the variable refers to the region of the program where, let's say, how the program is being represented, or where a variable is accessible, what's the access level of that variable. So understanding scopes is vital to prevent errors and to write clean, manageable code. So global variables, as you already know, they can be declared outside of any function, right? And can be accessed anywhere in the program. While it's useful, they can make debugging difficult because they can be changed from anywhere in the code, which makes the code vulnerable to changes and type related errors, right?